In this lecture, we are going to look at our first trading algorithm, which is called a trend following strategy. This is a traditional trading technique, which is not based on machine learning. If you recall, earlier in the course, we talked about simple moving averages. At the time, they probably didn't seem that useful. In this lecture, we will see how the simple moving average can be applied to build a trading strategy. Okay, so the best way to understand the trend following strategy is to look at it visually. The basic idea is this. We're actually going to create two simple moving averages out of a stock's price. One will be called the fast moving average, and one will be called the slow moving average. Intuitively, we know that if we include more terms in the moving average, then it will be slower to adjust. That's simply because each individual value in the moving average will have less influence on the result. Therefore, if we had one moving average looking at the past 30 days, it would be slower than a moving average that looks at only the past 10 days. As you recall, slow moving averages are smoother, while fast moving averages are more jagged and react more quickly to the input. Okay, so that should just be a review of what we learned in a time series analysis. Alright, so the basic algorithm works like this. I'll start by telling you what it is, and then we'll try to break it down to make sure it makes sense. The key is to look at the points where the fast-moving average crosses the slow-moving average. Whenever we see the fast-moving average cross the slow-moving average from below, we consider that a signal to buy. Whenever we see the fast-moving average cross the slow-moving average from above, we consider that a signal to sell. In between these values, we'll assume that we hold the position we were in previously. For example, if your previous action was to buy, then that just means you're holding stock, and hopefully while you're holding it, it rises in value. Okay, so crossing from below means buy, and crossing from above means sell. The question now is, why does this strategy make sense? Let's consider the first case where we buy, because the fast-moving average crosses the slow-moving average from below. This means that the stock's price is trending upward. The fast-moving average captures this upward trend, but the slow-moving average is taking a bit more time to react. Of course, this is predicated on the hope that this upward trend will continue. Now consider the case where we sell. We sell when we see the fast-moving average cross the slow-moving average from above. This means that the stock is trending downward. The fast-moving average captures this downward trend, but the slow-moving average is taking a bit more time to react. Again, this is predicated on the hope that this downward trend will continue. Let's now talk about some assumptions and restrictions we've just made. Firstly, in the following lectures, we will assume that you will not short sell. That is, either you will hold stock or you will hold cash. So you won't be able to make money when the stock price goes down. Second, and this one's pretty obvious, we are only working with a single stock or a single asset, such as the S&P. Of course, if you wanted to run this algorithm on two assets, you could do that, but they would be completely independent. Third, we assume that whenever we buy and whenever we sell, we take this action using the entirety of our wealth. So suppose we're holding cash and we're going to buy. That means we're going to buy every share that we can, and after that, we will hold zero cash. In reality, this is not exactly possible because traditionally, you can only buy whole shares, not fractional shares. Furthermore, when we sell, we're going to sell every single share that we own. So after selling, we will own zero shares of the asset under consideration. Now, it's important for us in the upcoming code lectures to get the timing right. In the rest of this lecture, I'm going to outline roughly what the code will look like, so you will have a chance to consider it as a thought experiment before we actually run the code. It will seem kind of strange because we're talking about trading, which implies that we're doing some action like buying or selling some shares of a stock. But in reality, all we're going to do is manipulate some values in a data frame. So in practice, it may not seem like trading, but keep in mind what it represents. People call this paper trading because you're simulating what would happen in a live environment. In fact, if this were 100 years ago and we did not have computers, you would actually do this on paper. So it will seem strange, but it does actually simulate trading. In later lectures, when we discuss reinforcement learning, we'll actually build an entire program that separates the trading logic from the market so that they exist as two separate entities in the code. This might make it more clear what we are actually simulating, and it may appear more natural. Furthermore, this will help you kind of sanity check everything we're about to do. What we're going to do is implement the trend following strategy once in the next lecture, and then once again using a reinforcement learning paradigm, and you will be able to verify that both methods give you the same answer. Okay, so anyway, I said we want to get the timing right. You'll see why this is important as we manipulate our data frame, because what we will do will seem quite odd. Okay, so first, let's assume that we calculate the fast and slow simple moving averages. These are just two new columns in our data frame. Let's assume that we know how to use these to generate buy and sell commands. So we've done that, and now we have a new column where it says buy, sell, or nothing. Okay, and let's recall that our table also includes the return for each day. Now you might assume that in the row where it says buy, we will get the return calculated for that day. In fact, this is not the case. So let's zoom into how the timing will work. As you know, in order to calculate the returns, the moving averages, and so forth, we will use close prices. Now, this is just an approximation. Let's assume that we can calculate the simple moving average using the price just before the market closes, so that if we do decide to buy, we will buy at the close price for that day. Remember, you cannot buy anything after the market is closed, just as you cannot order food from your favorite restaurant after it's closed. Again, this is just a very rough assumption, but let's assume that it holds. So let's say we purchase some shares at the close price at the end of some day, and say they cost you $100. We'll call this day time t minus 1. The next day, the price goes up to $101. This day is called time t. Note that the return, which is 101 divided by 100 minus 1, is the return at time t, not time t minus 1. So the return that you get corresponds to the day after you buy your shares. So what's the consequence of this? Basically, it just means you need to make sure that your returns line up properly in your data frame. One way to implement this, which will make things easier for us, is to simply shift the returns themselves backwards by one step. This is because, in pandas, operations tend to happen along rows, and so doing operations across different rows is more challenging. By placing the next day's return along each row, we can more easily calculate the returns from our algorithm. So instead of discussing this theoretically, let's look at how we're going to do this in code. Okay, so at this point, all we have are two moving averages. The next step is to determine where the fast moving average is greater than the slow moving average. We'll call this the signal column. The next step is to shift that column forwards into a new column called previous signal. Because pandas operations happen row-wise, we can now check by using these two columns when the fast-moving average crosses the slow-moving average, either from above or below. If the previous signal is false and the current signal is true, that means it crossed from below. If the previous signal is true and the current signal is false, that means it crossed from above. Okay, and so each time this happens, we'll say we want to buy or sell. To do this, we'll create two new columns, buy and sell, and these will contain booleans. The buy column will be true whenever we see the crossing from below, and the sell column will be true whenever we see the crossing from above. Please note that this table is not intuitive, so you may want to go through this slowly to ensure that this logic makes sense. Next, we're going to have a column called isInvested. This column will tell us whether or not the value of our wealth will be affected by the returns. If we are invested, then our wealth will change by that day's return. If we are not invested, then our wealth will stay constant since we are just holding cash. So in the code, we are going to use the pandas apply function to assign this column, but in this lecture, I'm going to show you a basic for loop, which is hopefully more intuitive. So we're going to start by creating a global variable called isInvested, and we'll always start off not being invested, so isInvested is false. Next, we're going to loop through each row of the data frame. Inside the loop, we're going to check two cases. If we are invested and the command is to sell, then isInvested becomes false. If we are not invested and the command is to buy, then isInvested becomes true. Otherwise, we do nothing, and isInvested remains whatever it is. At the end of the loop, we assign the variable isInvested to the column isInvested. Now, one important thing to notice about this column, isInvested, is that, just as we discussed earlier, it's off by a day. Why is that? This is because if we buy at the end of today, we are not technically invested and earning or losing money until the next day, when we've calculated the return. However, having this column like this is convenient, in my opinion. Note that there are many other ways to implement this algorithm, so if you don't like this idea, you're always encouraged to design your own version of the code. In fact, in my pure machine learning courses, that's often my initial instruction. Machine learning students should be able to take an algorithm description based purely on the theory and implement that theory in code without any assistance. Other people's code should be completely irrelevant. So you may want to take that strategy here. Remember that I'm not telling you how you should implement this. I'm simply sharing one possible example with you. You are strongly encouraged to write your own, whichever way is most intuitive for you. Okay, so the final step, once we know whether or not we are invested, is to calculate the return of our algorithm. In Python, since true equals 1 and false equals 0, we can simply multiply the isInvested column by the shifted return column and then sum up the results. Remember that we shifted the returns back by 1 day, so we're actually getting the returns for the next day. That's why there's no need to shift the isInvested column. So why does this make sense? Well, if we are invested, then we will get the return for the day we are invested. That's equivalent to multiplying by 1. If we are not invested, our return is 0, since we are just holding cash. So that's equivalent to multiplying by 0. Oh, and by the way, we'll be working with log returns, so the total cumulative return will just be the sum of the individual daily log returns.